Right, welcome back. I've not done any videos in a while, I'll be honest. It's just been a bit manic, a bit busy, sorting stuff out and still getting settled in to the new place. But I thought I'd let you follow through with this one. And this is a CNC machine billet hose connector for a factory style fitting onto a push fitting with a Jubilee clip. Now I've been asked to make nearly 200 of these. There's 3 different options, or 3 different sizes, shall I say, and it's 200 combined, not of each one. So for me, as starting up my own business and stuff like that, this is a big project, you know, this is a big bit of work for me. So we've got a turned piece here that we can turn on the lathe, radiuses, some grooving. It's not very good finish on this one. These are the samples that I was given. Now what you have got is these bayonet, it's hard to see them, but you can see them bayonet pieces here that I think they just lock into something. Now that piece, you can see the profile of it. That will have to be machined as one piece all the way around. Then what we're going to do is we're going to put it in the mill and we're going to mill out that profile. So we'll turn them first, bore them, turn them, do all that side of it. Then we'll put each one in the mill in a fixture, held on some sort of mandrel, bolted down, nice and solid, without marking or damaging anything. And then we'll come in with a milling cutter and we'll just mill around this profile, which is on both sides, 180 degrees apart. Programming this is all a bit new to this stuff, so you'll have to bear with me. There's probably easier ways and quicker ways. But that there is the profile of the part. It'll be easy to show. This one's slightly different, but here's another one, different size. So this one here, you can see I just milled this just as a test, just to see if it kind of matched up. This one's ever so slightly different, where it's a, I think it was a 5mm fillet and a 4mm radius. This one's actually got a bit of a flat across the top, quite hard to see on there. So they're slightly different, so we've been drawing them up and we've drawn this in Fusion 360, and then all I've used this for is to get these points here. If I click on one of them points down in the bottom, it gives me the XY dimensions. Now because my milling machine is a bit old school, the Prototrack DPM bed mill, it doesn't take G-code in the sense like any other, not even necessarily newer CNC machine would, just they have their own conversational G-code, and it doesn't accept a lot of the normal G-codes. It will just spit it out and say bad data, bad code. So the quickest way for me, because it's new, all of this is new to me, so I'm trying to learn everything in one hit quickly to deliver the parts on time, is to draw this up on the computer, print it out and add all the XY positions for the start and finish points of the arcs, the radiuses, the center points of the arcs. And then we drew that up. And then if I bring you over to the mill, try and, it's hard to get a bit of an angle because these things have got so much glare on them. That might be better. So you can see the shape there. So we've got a starting point at the top, just left of center, and coming in, milling around the part. Don't make any difference holding that. Just look like a numpty holding the clipboard. So yeah, we come in at the top here, do this profile round. You could mirror it, because I had all the points, I just put it in manually all the way around. There, I'll show you the program, which we've got. It's just recall event 1. I'm just learning how to do all this. I tried doing it using the AGE profile, so I didn't have to get all the start and finish points, and I'm doing something wrong because it just would not work it out. So we put it in manually. So we've got those mill events, arc events. It seems like a lot of info, but the computer has picked it all up in a sense of giving me all the X and Y points. I've just got to make sure I manually type it in and don't get it wrong. So yeah, there's that. Oh. Right, so there's the part again. And we're going to set something up now similar to that other plate I just showed you, but this time I'm going to mill the inside profile with a different cutter. So ignore that one that's just in there, and I want to be able to try and slip fit it over the top of this just to check we're good. So I'll cut it on the inside this time, and yeah, see if we can do it that way, because I don't want to chop one of the end of these off to just double check it, but it looks good. Depends if I can get, I don't even know if I'll have a cut small enough to get in there. That might be too small. Might have to just do the outside and check it on the shadow graph and see if it's the same. But yeah, so that's the first part. We've got 50 of these to do. This is the first one of the 3 different items we've got. So then we've got one of the bigger ones there, and another one of the bigger ones in there. So yeah, I'll follow on. I'll do some videos of it on the mill and on the lathe when I'm cutting them. The lathe, I'm actually lucky in the sense of we're not going to use the ELX. Next door to me is my landlord, who's a machinist as well, and I'm going to be able to use one of his machines and get that programmed up, because he's just got a bigger capacity, and it's more of a turning centre with an 8 turret tool changer. So we haven't got to mess around, and they'll be a lot quicker. So I'm doing a couple of projects on his machine, and then currently at the minute, I'm just deciding if it's something worthwhile to buy myself if I start doing more and more of these parts, because recently we've turned up some bits like this. And that was a prototype takeoff to be welded to something, to like a little pre-radiator with some push fittings. We've got some threads there for a water header tank off the car, some spacers, more spacers. So yeah, we've been doing a few little things on the CNC compared to so much of the welding and fabricating. So yeah, we'll see which way this goes. But I'll show you the parts being made along the way, and I'll show you when they're finished. Cheers for watching. Right, we're going to show you some of the milling of these parts that I've been making, and there's all the turned pieces. They're all turned up, and what we need to do is we need to mill the entire circumference of this, bar these 2 standoff sections that need to be left. It's just a bit of glare there, you can't really see. 180 degrees apart from one another. So this is the original one that the customer gave us. So I'll put a bit of tape on there just so I know what one's what. And here's the original. So it looks like they've done it the same way. These have been CNC turned, and then this section has been left on the entire circumference, and then it's been milled around and the radius is put on. So as I showed you in the one before, this is one of the profiles. If you can see there, 1 second, you can see the milling marks in the plate more than anything else. But this was just done to see if the radiuses were getting right and we got it right. It took a couple of goes to get the corners nice. This radius, the internal radius is 4mm and the external one is 1mm, and it's not quite flat on the top, but it's almost. So here they are before doing the fixture that we've made. This has got a T-nut in the bed and then a bit of studding bolted down to that, and then we've counterbored this and we've put a 19mm nut on there. Now this fit matches the inside of these, and it is a very snug fit on every one. So the repeatability needs to be bang on, because if it's 0.1 or 0.2 out, it shows up. Then what we've got is we've got this spacer, which is also counterbored. That drops on top of there. Then we put a nut down, just get it started on there. And I've done about 8 of these, just fine tuning it. All 8 are usable, that's not a problem. And then we're doing it up with a torque wrench, because I didn't want to torque it too much. It's got to be enough that the cutter doesn't make this rotate, but I don't want it too much that I'm putting any kind of load on there and potentially moving it. So I'll show you our program we've got. It hasn't got what's called a DNC key to allow proper CAD cam, so it has to be programmed at the actual control. So let me try and see if I can show you here. If I do program and then look, there you go, it draws it there. Let's adjust the view. Right. It's not a very good view. Let's adjust it. And look again. No, it's still drawing it in that bottom corner. So it's hard to see there, but that's what it is. Let's just go 3D, return, and look one more time. So that shows you what we're doing. So we're going to go ahead and do one of these, and I'll record it and show you. So set up with this, try and get this out of the light. That's just in DRO mode. I've got my home set to 250 on the Y-axis, because when it's finished, I don't want the part under the cutter while I'm trying to undo it. So I've got the table to come right forward, so I can get here, undo the part, put the next one on, and off it goes. Now to get the right finish, because it's only using a 6mm cutter to get into the radius, I could go to an 8, but it was still leaving it a bit rough because I could only do one pass. So with the 6, what I've done is if I show you here on tool setup, I've got 2 tools programmed. One is programmed, you can see that, 6.5. The other is a 6.08. Now that is the same tool, but what I'm doing by making that 6.5 is letting it step off away from the work, because this hasn't got a finish pass on just the program. It doesn't give you the option of a finish pass. It gives you a finish pass if you do a pocket or if you do framework, but if you've just typed it in the coordinates on all the XY points, then you can't denote a finish pass. So by doing that, we're doing the 6.5 as a rough cut, and then we step it into 6.08 to do a finish. And then in the program, if we go into program, we got positioning move, then we go to the start, the mill and arc events, which go up to approximately, I think it's 16 or 17, there you go, 18, and then we're into tool 2, which is actually still tool 1, but this is the second pass, so a lower feed rate and a closer, I think he's taking point something on the final. So let's go back to there. We're all set up in our heights, so we got run. Let me move this, because I don't want to get that covered. And I'm just going to put this bit of alley I use up there, because I was doing it without this, and I've given it a clean and a sort out before I do this video. And this is just to stop the coolant getting sprayed everywhere. So going to the program, we hit start, that's telling me to press go. Load tool 1, which it thinks is a 6.5mm end mill, but we're actually still on the same 6. Start the spindle, start the coolant, and press go. I need another coolant hose so we can come from both sides, because it doesn't work very well like that. See, now that's thinking I need a tool change. So if I show you that pass there, it's not too bad, but we don't want such a big step. So now it thinks tool change. So I tell it I'm loading tool 2, and we go again. This is the finish path, sorry, at a much slower rate. Now this is only tickling it at 100mm a minute. That's where we're at on the programs. Path's not very good view. Running. To show you, we've done some practice ones. Well, these are actually finished parts, but it was just trying to get a nicer finish. Now I know the feed rate, the finished feed rate of 100mm a minute is really slow, and if we went too deep on the cut, I don't know if you can see that, but it left a step visible in the part that I didn't like. You can see it more pronounced there. Still really faint, I'm just being fussy. These are one of my first CNC patchwork jobs that I've got, and I want to do more of this sort of stuff. So I want to get them as good as we can. It's only a hose connector this is for, and if you look at the original that they currently get, their finish is sort of the same. So I'm happy with what I'm producing. Done. What I need to do is, these do have auxiliary functions that you can put into the program as well, and I want to get that done to turn the coolant on and off using the auxiliaries, because it's just one more thing that I've got to do. I have to turn that off manually. So there we go, that's the program done. I'll turn off the spindle. It gives you the option of running your next part, just press that and it will go again. I'm just going to put you on the stand here, and then I can take this away and I'll show you the part. It's the only downside of an open bed mill is the mess. While I'm here, I'll load the next one on. So there's our nut off, and a little cup. There's our part. Let's get a bit of tissue. And I'll try and show you the finish. Hopefully there's not too much glare off of the actual part. And we'll show you here. So there it is. That's the finish. I'm happy with that. That's a nice part. And just to compare it to the original, can't complain with that. It's got a nice finish. It's got real nice radius in there, real nice surface finish. Again, if it had a bigger radius and I could use a more rigid cutter, but there's only so much you can do with a 6mm cutter, having to go, including the little space on the top, is 25mm that I have to drop down, or 23mm. But that's as good as I could get it. So we get the next one, slides on there, spacer back on, put the nut back down. And then use our torque wrench again, and there we are. Let's get our guard. I can see myself going to a VMC type mill if I get the chance in the near future. Work going well, because I'm not a fan of all the coolant everywhere and stuff like that. So now we can click on there. If I take you back out of it, we're good to go. We just press next part. It says press go. Load tool 1. Press go. Spindle on. Coolant on. And we're going on part number 2. So there you have it. There's the parts we're doing. We've got all these left to do. These ones are done. And then we've got to move up to another size. The next size is a fair bit bigger than this. I think these are 61 overall. The next ones are 74, 75mm diameter, I think. So we'll program that, but they're same parts, same sort of things, just different sizes. So yeah, I might show you some photos when they're done. Cheers for watching. Bring you in, a little bit of footage, and there's all the finished billet connectors. Happy with how they came out. So we've got to go to the next size now. I think these are 40mm ID. The next ones go up to a 50mm ID with, I think it's a 73mm OD. So a bit bigger than these, and we've got to do 100 of the next ones. I'll show you them when they're done. Cheers for watching.